Hi everyone, in this video we are going to cover basic measurement with the camera and the basic functionality within the Vision software. If you haven't already, please watch and implement the exercises from the previous video tutorials in this series. This covers the camera setup and the camera calibration. Without having carried out these steps, you will not be able to do anything that we cover in this video tutorial. Now, if you have covered the previous steps and the camera is set up and calibrated, we can go ahead and switch to the camera now and get some measurements. So we go to the top left corner and select probe, camera magnetic joint. The software will ask us to change. We roll the probe forward and off, keep it somewhere safe. We can then connect the camera, and at this stage we can press OK. The software will switch the camera on and turn on the vision option, and we are now ready to get some measurements. Before we can gather any measurements, we need to make sure that the camera is looking at the artifact or component that we are measuring, and we also need to make sure that the image is in focus. So using the joystick, as this is quite a big sweeping move and we also need to get the Z height correct, we will drive over to the component. In this case we are using the glass graticule again. This is the easiest to do training and measurements and calibration on, so that's what we'll be using for this exercise. And you can see I'm just using the joystick to drive over, and then I'll rotate the Z-axis to get it somewhere near. And that is pretty good. You can stick with that if you want. If you really want to fine tune it though, you can use the autofocus. So it's these reading glasses with the letter A next to it. Click on that. The software will jiggle the camera up and down, trying to find the best focus. There we go. And at this stage, it's generally a good idea, if the part is the same height, to lock the Z-axis. This can be done on the joystick with the padlock, or also on the screen via the readouts. So if you use the digital readouts, the DRO, you can right click on the axis you wish to lock and select lock unlock axis. This is an easy option if you don't have the touchscreen joystick. Okay, at this stage we are ready to measure. As mentioned in a previous exercise, you can also use the light ring if you are struggling to get a good edge on the feature. Again, this is ring light controls. Left click on the large ring. This does the bright LEDs. You see this actually offers too much of a reflection, so we will not be using it in this exercise. And if you're also struggling to differentiate between the part and the backlit plate, you can use the UV. This sometimes gives a sharper edge. In this particular case, it makes it worse. So most of the stuff that I find, you don't need to use either LED. You can just use the camera as is. Okay, we are ready to now start measuring. We will start this tutorial measuring circles. As mentioned in a previous exercise, if you do need to move the camera around now, we can press the mouse wheel in. So this is the mouse wheel on the image and drag the camera to follow the mouse. So we will drag this down and we will start off with the 8mm circle. Rolling in and out with the mouse gives us the field of view. And before we measure, we need to make sure we select the correct feature. So this is in this feature selection window. The drop down box, we will choose circle. And because we are measuring an edge, we need to make sure the inspection method is set to edge detection. Now we are ready to measure. We will define the circle with 3 left clicks. So 1, 2, 3. These are evenly spread on the outside edge. We then slowly move the mouse outwards. This defines the scanning window that the software will use to look for an edge. And the 4th left click starts the scan. So there's the 4th left click. The software now looks for an edge within that scanning window. This is logging the points here. And you'll see it defines the feature. So it's an 8.006 circle with a 4 micron roundness. And because we are going to do a program, we will set this as a reference. This is now the origin of our program. This green window is showing the Vision software's or the camera's field of view. We always want our measurements to be in the center or as close to the center as possible. So I'll move the camera now to step forward so we can get the 6mm in the middle of the view. We do the same thing again. We don't need to reselect the circle feature. It is now in circle measuring mode. So we do the same thing again. 3 left clicks. 1, 2, 3. Move the scanning window just outside. We don't want it too big. We don't want it too small. This is probably just about right. And the 4th left click starts the scan. So we hit the green tick and you'll see it writes the feature into the software. We would like a rotational alignment, just as we do with our 3D system. So we will construct a line between the two and set this as a reference. And this is now using that alignment as the reference system. And to finish off the circle measurement, we will do the 4mm also. So 1, 2, 3, move it away, 4. That executes the command. And again, it writes that feature to the software. We can now dimension this like anything else in ABELINK 3D. So we double click the circle, move it away, drop it down, double click the circle, move it away, drop it down. And we can also dimension between the features as so. If we right click on any of these, we can fill the tolerances in. This is outside the scope of this training exercise. It works exactly the same as the standard software, so we'll not go into that. But we have now measured the 3 circles in a program. And we can run this program back if we want. So inspection, play. Click yes to this, and you'll see the camera automatically goes to the location, scans the edge, picks up the next circle, moves, picks up the next circle, and updates the dimensions on the screen. So that is how we measure circles with the camera and vision software. We will now measure some lines. So this will be done on the middle profile section of the graticule. So again, we'll zoom in. So in this particular case, we need to switch now from circle to line in the select feature drop down box, so make sure you're on line. We're still going to use edge detection, and the line works off 2 clicks to define the line. So we'll click here, that's 1 left click, and here 2 left clicks. We now move in or out to set the scanning window. This works the same as on the circles. We don't want it too big, we don't want it too small, but here's okay. And then the 3rd click starts the scan. So you'll see it picks up that edge. Again, we need a reference system, only a 2D reference system as we're not measuring planes. So we will set that line as a reference. We'll then measure this line, so 1, 2, set the scanning window by moving the mouse outwards, and 3 sets the scan. We'll hit the green tick as we can't have 2 lines as a reference. And we will construct a point where the 2 meet and set this as our origin. So point, construct, left click on this line, left click on this line, set this as a reference, and we now have a full coordinate system. We can go around taking some more measurements. So 1, 2, scanning window by moving out, and 3. Again, I'm trying to move whatever I'm measuring to the middle of the field of view. So 1, 2, scanning window. 1, 2, scanning window. And you can start to see we have the features written into the software, and they can be dimensioned just like normal. So left click, left click, left click, left click, and we can also define the angles by clicking between them. As mentioned, I'm not going to cover the dimension and tolerancing. This is just an example. And as the previous exercise, inspection, play, click yes to that. You can see the camera will move and pick up the measurements just as we selected them. And update the dimensions. And that is a fully functional program measuring lines. We will now measure some arcs. This is used when you don't have a full circle to measure, so any radius or little curves of arcs where it's not a full circle, we will use the arc feature. It is defined very similar to a circle. So I take arc. Again, try to get the thing you are measuring right in the middle of the camera field of view. And we define 3 points just like a circle. So 1, 2, and 3. Move the scanning window just like the previous exercises, and the fourth left click executes the scan. So we'll use that as a reference, and you'll see it displays as a radius. It also dimensions as a radius. We need a reference system, so let's go ahead and get some more measurements. We'll do this one now. So 1, 2, 3. Hit the green tick, and we'll draw a line between the two. Set as a reference, and that is the coordinate system fully defined. Let's get some further measurements. So 1, 2, 3. 1, 2, 3. 1, 2, and 3. Hit the green tick. Let's get some more dimensions. This is where you can really see the vision system and how functional it is. Measuring small radius like this. Highly accurate and precise. There we go. And just like the previous exercises, we can run this program back by going to inspection and play. Click yes for SPC. And you'll see the camera moves, looks for the defined scan area and picks up the edge. The dimensions then get updated, and at the end you get your summary. There we go. That's a quickly ran program. And that is how you measure arc features. As a final update to this video tutorial, I would like to just highlight, as you might be aware already, the overlay feature. So this is in Vision, and it's this sort of 2 sheets of paper on top of each other, or a sheet overlaying the other one. We call it overlays, and it allows different overlays within the Vision software itself. So at the moment you'll see dimensions. If I turn that off, the dimensions no longer display. You can also have features. And the other useful one is the recent images tab. So if we have toggle overlay and remember recent images, you'll see that we can actually use this feature. Every time the camera moves and pauses, it will log the image in the Vision software itself. And you might already be able to see why this is useful. It allows bigger single measurements for features that don't fit within the field of view. We will cover this in the next advanced exercise, but it's good to cover it in here so you can see how it functions. So every time it pauses, it logs that image, and you'll see it logs all of the images on the screen at once, giving us a bigger field of view for measuring larger components. So this is the overlays toolbar here, and the different options are in here. If you need to clear the images, we say clear, and we go back to how it was. that is the overlays feature. This concludes this video tutorial. Please move on to the next one to cover advanced functionality and all remaining features within the Vision software itself.